Hello, and welcome to Nature Connects, the Nature Conservancy in Massachusetts webinar series that connects you with scientists, experts, influencers, and our partners from New England and around the world. Thank you for joining us today. I'm your host, Chris McGuire. I direct the Nature Conservancy's ocean program here in Massachusetts. Our team works with recreational and commercial fishermen to sustain abundant fish species. We work with oyster farmers to support coastal habitat restoration projects. And pertinent to this webinar, we're working to accelerate offshore renewable energy deployment while enhancing biodiversity. During this webinar series, we've heard about various aspects of offshore wind development. We've covered the important climate mitigation role of offshore wind, how to evaluate its costs here in New England. We've heard how we monitor and understand wind development effects on species and habitats, and how we reduce risks from possible interactions with offshore wind infrastructure. We've also talked quite a bit about how little we really know about the ocean and the species that live there, and conversely, how much we still have to learn. But what we do know is that the ocean is stressed, and the world is facing a dangerous and worsening decline of biodiversity, which has serious consequences for the health of species on our planet, like us. So today, we're going to be talking primarily about biodiversity, what the scale of offshore wind development across the globe could do to help actively stem biodiversity declines, and how the Nature Conservancy is supporting the focus on biodiversity within the offshore wind sector. When we use the term biodiversity here, we mean not only the variety, but also the abundance and the resilience of species and ecosystems. There's a large group of global nature, development, and business organizations who recently issued a call to action for a clear and overarching nature-positive global goal. Nature-positive means halting and reversing nature loss by 2030 and driving a full recovery of biodiversity by 2050. In other words, the call to action is to bend the curve of biodiversity loss from its current negative trajectory to a positive one. This means that halting the loss of species and drivers of biodiversity loss will not be enough to alter the trajectory. We also have to take systemic and deliberate actions to restore and enhance nature. Today, we're going to learn about some of these global initiatives and how they're trickling down to the country or state levels. We'll hear how offshore wind developers are beginning to ask what they can do to improve biodiversity at the project level, and what kind of information they're telling regulators and organizations like the Nature Conservancy that they need to accomplish this. Our speakers today have been building their expertise on the topic of nature-positive actions and offshore wind, and I'm happy to be hosting this conversation with them. Our first presenter is Trisha Yardley. Trisha leads the Nature Conservancy's offshore wind program. She's an environmental attorney with 25 plus years of experience working on complex legal, policy, and legislative matters at both the federal and state levels. For the past 3 years, she's been working with partners at state, federal, and global levels to standardize an approach for the selection of biodiversity positive actions for offshore wind projects. Today, she's going to set the stage for why offshore wind companies are willing to consider nature-positive actions. She'll explain the mitigation hierarchy. What is it, and why do we use it? How the Nature Conservancy is working to build consensus about our nature priorities, and TNC's unique role in creating tools to standardize the way we talk about science and related to biodiversity. Then we're going to hear from Dr. Marta Ribera. Marta is a spatial ecologist with more than 20 years of experience analyzing coastal and offshore data across the country. Her work focuses on supporting decisions we make across the ocean with the best science, data, and tools available. She works with the Nature Conservancy's North America Science Program, and she's an expert in acquiring and analyzing complex data sets from multiple sources and integrating physical, ecological, and socioeconomic data into easy-to-use apps, tools, and other visualizations. Today, she's going to talk about the questions we're asking through the data, like what species and habitats are in this location? What is important? How do we decide? And she will walk us through a tool her team developed called the Marine Mapping Tool and some of the changes that team has been making to support net positive decisions around the region. As you think of questions for Trisha and Marta, please enter them into the question and answer box at the bottom of your screen. We're going to hear both presentations before we start answering questions. So thank you so much for joining us today. And Trish, I'll pass it along to you to get us started.
Great. Thanks, Chris. Let me just get going here. And just
That looks good.
checking. You got it? Okay, great. Okay, so I'm going to get right to it. When we talk about biodiversity, we're usually talking about the variety of life found in a place on Earth or the total variety of life on Earth. Sometimes we measure this variety by counting species in an area. This is called species richness. And by this measure, the Amazon rainforest has more biodiversity in birds than Great Britain. But raw species count is not the only measure of biodiversity. For example, the animal count for species on land is larger than in the ocean because there are huge numbers of insect species on land. But that doesn't mean that insects are more important or a better indicator of biodiversity than animals or habitats that live in the ocean. Deep corals support genetic variety, ecosystem functions, and resilience of the broader ecosystem. These are also important measures of biodiversity in addition to species richness. And as Chris mentioned in his opening remarks, we are in the midst of a dangerous and serious global decline of biodiversity. This decline threatens 1 million species and has the potential to impact billions of people. This graph from the World Economic Forum shows that between 1970 and 2018, there has been an average 69% drop in the abundance of monitored populations, representing 5,200 species across the globe. There are a number of leading causes of this biodiversity decline, including unsustainable agriculture practices, logging, and, as we all know, climate change. And in response to this global decline in biodiversity, nearly 200 nations signed what is referred to as the Kunming-Montreal Global Biodiversity Framework in 2022. This is a commitment to halt and reverse nature loss by 2030. As a result of this framework, the Nature Positive Initiative that Chris mentioned was launched by 27 of the world's largest nature organizations, including the Nature Conservancy. And this graphic shows the current trajectory for global biodiversity, a downward trajectory, and the goal of getting to net positive for nature and biodiversity by 2030 with full recovery by 2050. The Paris Climate Agreement and the Biodiversity Framework have both been drivers of policy and finance levers, a number of which are bulleted on this slide. For example, the European Union's Corporate Sustainability Reporting Directive requires companies to measure and prove the success of their sustainability claims as part of their corporate reporting obligations. The biodiversity-related bidding criteria that are used by countries around the North Sea drives offshore wind companies to compete for contracts on how much ecological benefit they can deliver, and not just on price. Because of this policy and finance context, offshore wind companies are designing for biodiversity to win contracts in other countries. But bear in mind that while there is this robust regulatory pathway in Europe, here in the United States, the lever for biodiversity positive has been primarily state contracts and corporate finance. This has created a demand from offshore wind companies for guidance about how to make decisions about which species and habitats they should be focusing on for their voluntary biodiversity positive actions in the United States. But regardless really of the motivating factor, the ambition to contribute to the Nature Positive Initiative aligns closely with TNC's mission and our focus on addressing the biodiversity crisis. So on this slide, we have two terms, and you'll hear us use both of these terms today. We've already used nature positive, but it's important to know that they are different and how they relate to each other. NPI, or net positive impact, is the concept of delivering biodiversity positive action at a project level, a singular project level. But an individual offshore wind project cannot be nature positive on its own. It can produce a net positive impact, and it can contribute to those global nature positive goals that we've looked at on the earlier slide. Working to deliver net positive impact and outcomes at a project level is part of what we call the mitigation hierarchy, and it can only become a focus once no net loss for a focal species has been achieved. So we're going to talk a little bit now about the mitigation hierarchy. The basic idea is that before we can even begin to talk about moving a species or a habitat from a declining status to an improving status, we have to be able to get to zero for that species. In the mitigation hierarchy, getting to zero is referred to as no net loss, and that's measured by how well we avoid, minimize, and mitigate the net impact to a species or habitat over time. On this slide, no net loss is represented by the white horizontal line at the top of the slide. But keep in mind that even if we required every development project to get only to the no net loss line, it still would not be enough to reach the 2030 and 2050 nature positive goals for biodiversity. We really have to make an effort to produce net positive outcomes for all projects at the project level. And I'm going to walk through a little mitigation hierarchy practice exercise with this slide and hopefully draw some of this information into sharper focus. So in this hypothetical, we're going to pretend that the impact being created is from the construction of a new road. And I've selected the squirrel as my priority species. So I'm going to try to avoid impacts to squirrels and get at least to the no net loss line. But then I also hope to voluntarily go above and beyond to create a net positive outcome for squirrels. You can think about this first red bar with the squirrel picture as representing the additional impact to squirrels caused by collisions or displacement from tree cutting that we need to do to build this hypothetical road. The best way to reduce the impact is to avoid it in the first place. This is the first step of the mitigation hierarchy. So maybe we change the location of the road to a place where there are no squirrels or fewer squirrels. But even after we've taken steps to avoid, there's likely still going to be some squirrely squirrels in the area, resulting in some residual impact, which is this shorter red bar in the avoid column. To reduce this residual impact further, we have to select actions to minimize. So in this example, I've decided to install fencing to keep squirrels away from the new road. After all my valiant efforts, and they truly were, to taken to minimize impacts, and even though the residual impact bar is clearly smaller now, we still are not at the no net loss line for squirrels. So now we have to move into the realm of mitigation and offsets. In traditional mitigation, this might look like planting new trees in the same area to replace the lost habitat, or paying compensation for killed or injured squirrels. But that might not be the best way to boost squirrel populations. We may want to use an offset and plant those trees in another location where there are no roads or predators, or maybe even take an action to eliminate predators that attack squirrel nests. And it's with these choices that we might be able to go beyond zero to get to a net positive status for squirrels. I want to make one final point here, that every action taken to move squirrels above the no net loss line is voluntary. I'm incentivized to take these additional actions because maybe it was a condition for me to win the contract to build the road in the first place. Or maybe my investors are requiring me to take these additional actions in order to be funded. In the offshore wind context, even if a developer wants to go above and beyond the no net loss line, they still don't have much guidance on what animals or habitats should be priorities. So the question of what and who gets prioritized is an important one. You may have been asking, why is she focusing on squirrels? Who cares about squirrels when there are things like hawks or turtles? What about squirrels makes them the right species to prioritize? And if you were asking, why did she choose fencing to minimize speed bumps would have been a better choice, then you were asking the right questions. This is the world of net positive impact mitigation and biodiversity positive in the ocean. We have to think about all the information that's needed to make these decisions and the best ways to access that information. What kinds of tools might you find useful to help you make better decisions than I clearly made when I chose a squirrel and fencing? When I chose the squirrel, I didn't ask some really important context questions like, are squirrels at risk? Are they even in this area? Will the road increase traffic enough and at high enough speeds to add additional risk? There really isn't one approach or standard questions to ask before we prioritize something or some action to reach net positive outcomes. But there are a few frameworks that already exist that are being used now to make these decisions. If it's required already to focus on a certain species, a developer might decide to stick with that species for its net positive actions. For example, mitigation for endangered and threatened species is required by statute and regulation. The responsible agency will decide what kind of mitigation is needed and how much of that mitigation is needed. Communities may elevate concerns or have an expectation about a particular feature that can make it a priority for mitigation. For example, even though there's no legal requirement to avoid deep sea corals or to avoid impacts to birds that aren't listed as threatened or endangered, these animals and habitat may be very important for biodiversity. A developer could look to the community and organizations working on mitigation to find out what's important to them. There are other criteria that inform these kinds of decisions, like the International Finance Corporation's performance standards. These standards guide sustainable development, and Performance Standard 6 is specific to biodiversity. But the point is that without a standard for what and who gets prioritized, each developer may choose a different who and a different what to focus on for their voluntary net positive actions. This is where context can be really helpful. Even without a uniform standard, being able to see the data in context may guide more standardized decisions. So on this finalish slide, here's what I hope will be a helpful analogy for why context is key and why having data without context can make decision-making challenging and outcomes less effective. So many of us have probably had an experience either babysitting ourselves or hiring a babysitter. And if you are given only the basic data, this is the address, this is the time, here are my kids' names, and here's what's expected of you, you'll probably be able to do an okay job. Maybe you get asked back to babysit again, maybe you don't, maybe your night goes okay. But it's probably more likely that this is going to be tougher than it has to be. If you were able to connect the data you have to additional data that provides context, like for example, Emmy is 4 years old. She only eats pasta with butter. She likes bedtime stories, and these are her favorites. She's afraid of the dark, and she needs a specific toy when she goes to bed and a nightlight on. Joey's 6 years old. He eats everything, but only with mustard. He needs certain toys when he takes his bath. He can help you get Emmy to bed. And he likes to make up stories at bedtime. If you have this additional context for the data, you're going to have a much easier night and a much easier time accomplishing these tasks. The kids are going to be happier and you're definitely going to be asked to babysit again. So this is why the changes that TNC has been making to its marine mapping tool, and which we're going to talk about next, have not only made it easier to decide what species and habitats to prioritize, but we're making it easier to connect to other data points that provide context. And we house this information in one place so that the user doesn't have to look to multiple sources to get the context they need. The last thing I'll mention is that we've been working on and leading several efforts in this space over the past several years. I'm not going to go into detail on them right now because we want to get to the tool, but we will drop a few links in the chat so that you can access the content shown on this slide. But for the rest of the webinar today, we're going to focus on the work we've been doing on our marine mapping tool. I say we generously, I really mean Marta. So I'm going to pass this over now to my brilliant colleague, Marta, to talk about the tool.
Thanks, Tricia. And as you have questions that come up, please type them into the question and answer box so that we can address them after Marta's presentation.
Okay, thank you, everybody. Thanks, Trish, for that introduction. Well, let's talk about data. And before you all start running away, I know, I promise this is not gonna give you a flashback of high school math or anything like that. What I wanna focus today is first take a step back and discuss a little bit the role of data and tools in facilitating the decision-making process. This is a critical and often unseen part of what we do at DNC and by many others in the region. And that is the base of a lot of the planning and siting work that happens in our coastal waters. I then want to focus on net positive decisions and describe some of the questions we're asking to the data. And finally, I will look at the tool that Chris and Trish mentioned and talk about the tool that we developed a few years ago, show you what you have, you'll be able to access right now, but also look into the changes that we're planning in the next month to support some decisions around this topic. So let's get started. So the goal of my job is to make sure that the best science and data are used for decision making. And that's not a unique goal to me. There's a lot of organizations and federal and state agencies that are supporting this goal as well. In this graph, what that means is to go from the left side of your screen to the right side of the screen. So from data to decision making. The first step of when we talk about data, and Chris mentioned it a little bit in his introduction, is we talk about filling the gaps of what we understand about the system. So either doing some research to fill the gaps, as we've discussed in past webinars, either with birds or marine mammals or fish. We're also talking about monitoring, which is really critical to understand how the species are doing over time. But also, I pack into this also the work we're doing on creating best practices and direction, so we don't have to reinvent the tool every time we start a project. In the last about decade or so, we've been focusing as a region a lot on this next step, which is making data accessible to all. And for a good reason, obviously. You cannot make decisions on data that you don't have access to. That has different takes different shapes and sizes in different ways. One of it is converting data to accessible formats, and that sometimes means getting to somebody's barn or basement and grabbing a box and getting through all the papers. But sometimes it's like tables on computers that are not online and making sure that those layers are accessible to everybody. Sometimes that work relies on, as a group and as a region, agreeing on what we call the best data available. So we can all agree on where we start. So we can all kind of speak the same language. And finally, there's tools like the ones developed by a lot of our regional planning bodies, by the Regional Wildlife Science Collaborative, by NOAA, and by many others that actually made the effort of making data available online. That means that you can go to a website and look at the data and look at the maps. Now, you would think that that's it. We're done. Our job is done. We can make decisions now. Well, it doesn't work that way. What do they say? That if you build it, they will come? That doesn't work with data really well. And the problem is that these framework that I'm showing you right now is only accessible to people like me, people that I have the software, the computers, the time, and I have the knowledge, and I've trained for many years to how to do this. And I have and will, I support and created layers to support decisions across the region. But for the many people that are not consultants or they don't have staff, GIS staff like me, this is actually not accessible. So even if the data are online, they cannot use it to make decisions. So that's why, as Tris mentioned, for many years, we have been focusing on what we call context and interpretation. And that means creating the metrics and analysis that really answers the user's questions. And that not only encourages participation, which is critical, and we know that a process that's participatory, it's richer, and it also builds trust, which is something that I'll bring back throughout my presentation over and over, because it's really critical that we'll build trust on the data that we use. So what are the questions we're asking of the data? Well, the first question that Trish also mentioned is the who and what is in the sites, to know what species and habitats people use within the area of interest. That means that within a site, we can understand what fish are there, what marine mammals, what birds, and even what uses also overlap within the site that we're interested in. So it's really an overlap analysis within a space. If you look at the data that's available online right now about these type of species, you're going to see something like kilograms of biomass and density of individuals and fishing hours and all this stuff. For an expert, this is perfect. You know what to do with it. You just kind of make decisions out of it. But for a lot of people, you need to start teasing out a lot of the patterns that kind of drive the decision making in the region. So for example, instead of this, we can start understanding what species use this area persistently at high levels. What that means is that species comes back to a similar spot year after year, probably driven because there's some seafloor structure that's increasing aggregations or some type of oceanographic pattern that's driving them to the foot. There's also, for migratory species, we're trying to understand when we are using certain areas and at what times. So when we're trying to build up some mitigation projects, we do them at the time that are the most effective. We're also trying to understand not just one species, but these high biodiversity levels, so we can try and understand the patterns across the region. And finally, for users, we're trying to understand how dependent certain uses are of certain areas. So when a project gets established, we want to understand what the impact is going to be. As Trish mentioned, our next question we're asking, especially related to MPI projects, is the what is important. And I'm sure you heard as a kid, and Trish mentioned it perfectly well, and you tell your kids and grandkids that when you treat everything special, then nothing is. And I'm sure there's a Bluey episode for that as well. But really what that means is setting up a framework so we can all agree what's important in our region. Sometimes what the first thing that we think of is the species that are mandated or they're required. Those are species that are threatened and endangered. But also we're trying to expand that through some frameworks like the standard, the PS6 criteria that Trish mentioned, to include species that have limited or declining ranges, like the piping plover, for example, or areas of high diversity, or areas that support key processes and features that are driving those species, not just now, but into the future. So really what we're moving into is this question of what's connected. We know that species not just use an area throughout the year, but they actually use different areas throughout their life cycle. And understanding those connections is really critical. So for example, if a species uses an area offshore part of the year, maybe it uses an area coastal for breeding. And maybe it's possible that what we can do for that species that is above that no net loss, it's not offshore, it's actually in the coastal areas. And it's possible that we can prioritize these high diversity areas or these resilient habitats in the coastal areas. Those are habitats that are supporting diversity as climate changes. And maybe that's the focus on our mitigation and projects into the future. So I think understanding how that system is connected with data and with tools is really important. So I'm going to transition that to this marine mapping tool. And the marine mapping tool, when it was built in 2021, it was built just to answer the first question, the who and what are in this site. It was really to support the states to kind of participate in the siting process and to understand what are the key things that we should care about in an area that where a project gets cited. It actually lets users select the site, and it provides a quantitative overview of what may aggregate there and start teasing the why behind it. What we spend the most time is trying to unpack the data from broad to species specific in a way that feels natural to users, so it just doesn't feel overwhelming seeing like 1,000 layers on the same time. And finally, it also provides context to numbers. But the most important thing I think it does, and hopefully it does, is to transparently link to the sources and also assess data gaps and quality. So you can get a sense of what the data you're seeing and how much certain areas have higher quality data than others based on the samples behind it, but also when it was collected, who collected it, what is the source. So this is not just the end of your exploration process. This is like the first step of your adventure, learning about the data. So next slide, I'm going to go through a video that I recorded previously, going through the tool as it stands right now, and I'm going to highlight some of the features. But I really encourage you to go to the link, explore the tool, kind of like go through all the data and try to like answer questions you have about the ocean. And the tool also has a connect button, a contact button. So if you have any questions throughout this process, I'll be happy to answer those. Just use that button over there. So let's go through the video. Hopefully it works. So what you see in the tool is it has like these two big sections. The one on the left, it has more graphs and menus. You have buttons and all that stuff. And the one on the right, it's more a map. And as any online map, you can pan, you can zoom in, zoom out, look at your area. And both things talk to each other, as you're going to see in a minute. And that line you see, red line in the middle, it separates two ecoregions. Ecoregions are areas that are unique on their species and features. So when we're comparing the numbers, we'll be comparing it to those regions. So to interact with the tool, what you do, you can select the project, and there's a list of projects there. So you can go down the list and just select the project, and it comes up. But you can also draw an area on the map, or you can upload a polygon if you already have a site that you're thinking of. So for this case, I'm going to sketch a project. And if you're from the area, you know that this is Stellwagen Bank, so probably, hopefully, a lot of stuff will come up. And the first thing you see is what we call these marine life and habitat flags. And why we created this is to give you like a first overview of what we think you should be like thinking of that is important within the region. And there's features, there's people, there's species, and you can actually expand the species and see different groups that have some regulatory connections. And for each of them, you can link to the information and see everything that's in it. And you can go to the data directly from there. You can also go to the data going through the menu on the left that has like divided in like three big sections. The first one is about features. So that's the seafloor stuff. That's sediment, depth, seabed forms, car bottom, artificial reefs, all that stuff. We can go to people and communities. Right now it's only communities. We're expanding that. And you can see how fishing communities are dependent on each of the areas around the ocean. And finally, we're also talking about species information. And you have marine mammals and birds. But for this, I'm going to talk about fish for a few minutes. Again, as we mentioned before, we're trying to unpack the data from broad to specific. So the first thing you see is this comparison of values across the region. So it compares the values of one site to the values across the ecoregion. So you can get a sense if it's higher and lower than what you would expect. You can also look at the different groups. And some of them are threat related. So they're related to climate change, for example. So you can get a sense like how you unpack different species together, how things are going to change. You can also change seasons. In this case, you have spring and fall data. So you can look at how the numbers change. And now like we got broader and now we're going to go finer. So look at species by species information. In this case, for example, winter flounder. And as I said, you can click on any of the graphs and the map on the right will come up. And what you see here on the right is on these like redder, darker colors is areas of that have higher biomass persistently. That means across time, they've been higher and higher all the time. And then in the legend, you can see links to the portals and some of the sources. And finally, let's go even more specific. And for each of the species, we can look at how these information changes over time. So let's look at our winter flounder, comparing information from collected in the 80s to information that we have for the last decade. And then you can see a little bit of how these information changes. And at the top of the screen, which I'm not going to show, it's information on how these data was collected. You can see where the samples have been collected, how you can trust all this data. So hopefully making that transparent link between what you see in the screen and the source of the information. And as I mentioned, at the top right, you can see a contact button. Please use it for any questions. So obviously this is a tool as it exists right now, but we've been working the last year on making changes to this tool to support MPI decisions. And what are these things that we're changing? First, the new version will be ready in January. We apologize for not having it ready right now. We've been working around the clock, but these are some of the changes we're gonna have. First, we're gonna connect this MPI framework that Trish mentioned to highlight what is important. I think that includes what's regulatory, but also any restricted species, migratory species, processes that are driving a lot of these aggregations. We're also expanding our area of interest to cover coastal environments. So you'll be able to see information about salt marshes and eelgrass beds and rocky shores that are really critical for a lot of species around our region. We're also improving the exploration on the data. So through summaries on the tool, you'll be able to connect the species to their habitats and the habitats to all the biodiversity levels within those habitats. So hopefully the exploration is a lot more seamless than it is right now. And finally, we know that people sometimes do not have an area of interest, but they have a species of interest. So we're gonna add a way to search just for the species instead of drawing an area. So you can start exploring the data just limited to that species. And then you can maybe after that, you can just be driven to an area that you're more interested in. Our next step for next year, once the new tool is released, is to connect this data to potential mitigation opportunities to kind of like do the next step. We know things work, and we know that a lot of people are doing great work in the region. So we want to make sure that the tool connects to some of those opportunities across our area. So before I finish, and thank you for following all this with me, I want to go back to this graph. And this graph is a little misleading because it goes one way. But what's really critical is it's actually a loop. And to really do the work we do, and I should say we, but it's not just me, it's like a lot of people at DNC, is that we really want to listen and we want to like change the data we collect and change the research that we do based on like how the information gets used. And this is the way it should be. It should always be a loop, so we're adapting as we go along, and it's not like a static framework. So we always like trying to build the tools and change them as new opportunities come through. So I think that's it. Thank you everybody for listening, and I'll just leave it to Chris to for some question and answer.
Okay, great. Thank you so much, Marta and Tricia. I have a couple of opening questions, and then there are some questions in the chat that we can work to, but please type your questions into the question, and not the chat, into the question and answer, so that we can move to those. So maybe, Tricia, I'll start with you. There were a couple of links into the chat that feature some of the other work that the Nature Conservancy is doing to build consensus around nature positive efforts. Can you provide us a little more information about those efforts?
Sure. When I first started at the Nature Conservancy, it was the first time I had actually heard of the mitigation hierarchy, and the concept of net positive impact on biodiversity was a concept that was starting to come up in actually conversations with offshore wind projects and offshore wind companies. And I was really curious to understand more about what that was and how it related to the mitigation hierarchy. So we worked with the Roger Williams University School of Law, the Marine Affairs Institute, to host a symposium, a 2-day symposium that was in the spring of 2023 on this topic of what is net positive impact on biodiversity. And we looked at this from a regulatory and legal perspective because we were partnering with the law school, and also brought in scientists to talk about some of the challenges with measuring success and measuring baseline, and how do we actually do this kind of policy initiative. And we brought together scientists and experts really from all over the world for that conference. There are links in the, I think, in the chat to the YouTube video presentations, but also to a summary report that people can access. And the other thing I would say is, speaking of working with law schools, we worked with Vermont Law School to produce a report that looked at how states use something that's called non-price criteria when they're selecting offshore wind projects. So you can require companies to compete on price, but you can also require, like the North Sea, many countries around the North Sea are doing, companies to compete on what they're going to invest in a community, or mitigation, or fisheries compensation. And we took a look at all of the states who were engaged in offshore wind around the country at their non-price criteria and how they use it in their contracting. And so there's a link to the report that was prepared there. And the last thing we did was work with the United Nations as part of their global compact, the Ocean Stewardship Coalition, which is a coalition of consultancies, environmental organizations, governments around the world, and ocean energy companies to prepare a paper that really was about what are the criteria, what are some of the recommendations for each sector that operates in the ocean to get to net positive impact. And so there's a link to that report and the criteria and recommendations that we made for the government sector, the offshore wind sector, and so on and so forth.
Great. Well, thanks for all those links. There's a lot to digest there. Marta, maybe I'll switch to you. Can you talk about some of the challenges for trying to collect all the data that you need to support the tool? And how do you make sure that the data in the tool stays up to date?
Yeah, that's a great question. So obviously, as many people know, collecting data in the ocean is not simple. It takes a lot of effort. It is costly. So sometimes we just don't, obviously, we cannot collect all the data that we want to collect. We would love to know everything in every space. But what we're doing really is relying a lot on our partnerships in the region and with different organizations and with different people that are collecting the data to make sure that first we're not like sampling the same place altogether. So like relying on like RWSC as an organization, so we all can communicate with each other is critical. And like the regional planning bodies are great to know like what's coming up, what's like people are focusing on, what we need to focus on, what are the gaps. And that like also just to understand what's going on. So that's how we like learn about new projects. We talk to the researchers and then just try to update the tool as much as we can, and as much as obviously we have funding for, to just try to just keep it up to date, and just making sure that the data there are the best available at that point.
Great. Yeah, thank you. There were a couple of questions that I saw also talking about like how maybe about frequency, like so that as you described, a lot of that underlying data is somebody else's data that we're serving up. Can you give us just like an overview of how frequent sets are updated? I mean, it's not every year, is it every few years? And you know, what kind of goes into that? Because there were some questions that I'm kind of
Yes,
combining that came in
and
about
it's
that.
critical to know when the data are updated. So hopefully the tool makes it very transparent, but it is dependent on the data type. So data that are collected like regularly, that's just fish data that gets collected every year. Those are data that can like come up in like a year. They can be updated pretty quickly. But they're data like models, like what you see in the marine mammals and birds. Those are models, and those models take time because it just not compares the data to like the samples. It compares to environmental conditions. So it just takes time to put that type of model together. And they normally get updated every couple of years, depending on like how like the priorities come through. So it really depends on the data, and it depends on like how much of the analysis is required for each of the data. So we're trying to update it as much as we can. And again, it's not like a regular frequency because we want to make sure we're adapting to when the needs are and just really update it when we find out that there's a new update.
Great, thank you for that. I'm going to go to one of the questions that has come through the question and answer, and there's still time to add your questions there. The question is, how are you coordinating with the people and the scientists in the offshore wind industry and those working for the industry to link them to your mapping tool? And maybe Trish probably has a good answer to that.
Yeah, I'll start, and Marta, you can play backup if I miss anything. But I mean, there's actually a lot of kind of forums initially, I would say, like the annual State of the Science. We're members of the steering committee for the Regional Wildlife Science Collaborative. We attend and participate in a number of conferences related to science and offshore wind and offshore wind. And so we have a lot of conversations with the companies and the scientists that are working on different aspects of offshore wind in these settings, and have really come to develop an understanding of what kind of information is missing, what kind of information would be useful and helpful to them, and how do we get it, and how do we create kind of the standards that they think they need to do this kind of work correctly. So a lot of it's kind of in that informal way. For this particular tool, the Nature Conservancy also established a very broad steering committee, and we brought in folks from federal agencies, from offshore wind companies, people who do mitigation and restoration work, consultancies, nonprofit organizations working in this space, so that as we made the changes to the tool, we could show them different mock-ups of the tool and ask for their feedback over time. And then Marta, who has the really hard job with her colleagues in our North America Science, would then take that feedback and kind of try to address those concerns and questions that were raised by that steering committee. And I guess the last thing I'll say is that we intend to do workshops with respect to the mapping tool. We're not done with the mapping tool. We hope to kind of continue to make additions to it that can support these kinds of mitigation decisions and better outcomes for the mitigation decisions we're making. And so we're gonna keep working in that space, and hope to do some workshops with this tool in the coming year.
Thanks. Another question that came in, and there's a couple of questions sort of about this. It's sort of about how do we obtain the data? So one of the questions is, do we obtain data from federal agencies? And what about proprietary data that's not public? And I know that there's a lot of work that's going on through the data portals and through the RWSC and others about that. But maybe Marta, if you want to speak to that just a little bit.
Yeah, that's a great question. So we're lucky in this region that we have the support of platforms like the data portals, because they make our life a lot easier. And make through those portals, a lot of the data that used to be accessible, they're now there, and they're just publicly available to everybody. So most of the sources, I would say all of the sources really that you see on the tool, are publicly available somewhere. And on the Northeast, that somewhere often relies on the data portal. There's some data sources that are not on the data portal that we're including. And just the reason for that is just because there's different priorities for different platforms. And I think as we move to MPI decisions and other decisions around mitigation, it's like you can start seeing, like, obviously what we need to support those decisions is going to be a little different than what the portals have decided that is the best for a certain offshore planning, which is their focus. So I think like we're basically, just to answer that question, sorry, I'm rambling, but the idea is that the data are available publicly, and that what we're doing is kind of like packing in a way that hopefully supports that decision making.
And I'll
Thanks.
add just on the proprietary piece of that, because it's really interesting. Just, from a legal perspective, you could have companies that are partnering with another company where they're using a new technology to do monitoring or collect data, and it is proprietary, like they've invented it, or they're developing an approach, and they they are treating that information as proprietary information. They're in the United States, which is something that doesn't really happen in other places. We have a federal Freedom of Information Act that treats those exceptions sometimes differently than the way states treat that kind of data and information. And so you could end up in a situation where the state has a different approach to that kind of proprietary information than the federal government. And that makes it difficult for companies to navigate, and also for public and people who are trying to access information to know when something's available or why it's not.
Great, thanks for that. Again, combining a couple questions, maybe this is for both of you, but what are some of our data needs that could benefit a tool like this, and how we make mitigation decisions?
The list is long. Yeah, so I think the more we need to understand really, and it's not like we're being very good at like just trying to like understand and like study species specific information for a lot of species. We follow a species like red knots, and we just try to collect that information. There's always more that we would love to know about that species, and we should study those species. But sometimes we're not like understanding what like those drivers or those like ecosystem driving features, like treating the system kind of more as a whole, and like what are those connections and the areas of connectivity between areas of shore and inshore. So kind of like to treating the system, not about like these individual species, but more as a whole, and trying to understand what are like the places that will really be supporting, that kind of really supporting the like aggregation of species now and into the future. And that's what we call the resilient sites. So I think like trying to like separate like our study of different species, which is really important and critical, to more like this holistic understanding of the system.
Do you
Yeah,
want
I
to add to that?
guess, yeah, I would just say that the other thing that we could really use that we don't have a good sense of is what works and what doesn't. So like we select mitigation, and we don't always have a good sense of whether it was effective for the intended purpose. And we've heard from a lot of people that work on mitigation that it would be really helpful to kind of have a compilation of um, you know, green light mitigation, yellow light mitigation, red light mitigation, like what do we know works well? And we can correspond that to the investment we're making in that mitigation action to the outcome. So the investment is worth the benefit, and versus the stuff that is just kind of more experimental, and we're not 100% sure if this is going to work well for this species or not, for this habitat or not. And it would be really great if we could, I think, kind of develop a database where we have a better sense and we can start to standardize the types of actions that fall into different buckets in this category.
Okay, one more short data question, and then we're going to need to start wrapping up. So the question is, besides accommodating net positive impact analysis, what other features do we want to add to the tool that the mapping tools don't provide? And maybe this is where Marta could talk a little bit about the synthesis that she does in the mapping tool.
Yeah, and I think like different tools have different roles. So we know that the data portals have an extremely important role of providing access to a lot of data, but they cannot like make it like cover everything. So what we do with our tool is really that, well, we mentioned that context and interpretation, and kind of guiding some of the decisions with a lot of other information that you as a user need to make decisions right away. And that's why like we treat them as separate tools, and like there's need for all these tools because they have different roles in themselves. So I think like just we think that our tool, just that's the place it has to support those decisions with a lot of context and interpretation and regional and temporal context. And we need to understand more like those changes over time, and we're trying to like add a lot more data into that, and also not just by the species but also the uses. So I think like it's just a different way of seeing the data that kind of like tease out some of those patterns. So hopefully that answers that question.
Yeah, maybe just quickly in a 1 minute, there's another question about data quality, resolution. How do we like bridge those? That's something I know that we've worked on a lot.
Yeah, so obviously there's data. So this is a regional tool. So this looks at data at a regional and hopefully more local in certain cases scale. But there's a lot of data sets that are a lot more finer resolution and local that this tool can accommodate. What we can do, I think, and we are trying to do in the future, is to connect to those projects better through the tool. So again, this is your first stop of your exploration of data. It's not just the last one. We know there's many other data sets that you should be looking into that, and they're very critical. But hopefully this tool is just your first step towards getting to that.
Okay, well, that's a great response to end on. Unfortunately, we're approaching the end of our time today, so we want to thank you for joining us, and thank you again to all of you who support the Nature Conservancy so generously. We will be sending everyone a follow-up email over the coming days with a link to the recording of this webinar, and they're available on our website at nature.org/massconnects. We really appreciate your feedback, so take a moment to respond to the poll that just popped up on your screen. And if you're enjoying our webinars, please be sure to share them with your friends and colleagues. You can follow us on social media at conserve_MA on Facebook and Instagram to keep up with our work and get updates on upcoming virtual opportunities to connect with us. And as always, you can register for future webinars at nature.org/MA webinars. Our next webinar in this series will take place on January 23rd of next year at noon Eastern Time, and we'll be learning about community benefit agreements. We'll speak with Lindsay Dugan, a senior community investment manager at SSE Renewables, to hear about her experience supporting over $419 million in community benefit agreements across Europe and Japan. And she'll be joined by Mark James, an associate professor and the interim director of the Institute for Energy and the Environment at the Vermont Law and Graduate School. And he'll review the Institute's new report on examples of how the US federal government and states are incentivizing and incorporating community benefit agreements into their offshore wind development process. We hope you can join us then, and thank you again, and have a wonderful afternoon.